Hi student. So here we are going to see one of numerical based upon sun and earth geometry. So numerical is that problem is that calculate the angle made by the beam radiation with the normal to a flat plate collector on May 1st at 900 hours, which is the local apparent time. The collector is located in New Delhi, which is having locations 28 degrees 35 minutes north and 77 degree 12 minutes east. That is the location of the New Delhi or that particular point. It is tilted at an angle of 36 degree with the horizontal and is pointing due to the south. So we have to calculate the incident angle, value of the incident angle by using this particular information. Also, they ask to repeat the calculation for 1200 hours of local apparent time. So, in this particular numerical, we have to find out the incident angle of that particular receiver or the flat plate collector, where the location is given and all information is given. So, obviously, we have to use this particular formula, which is the basic formula of incident angle. That is cos theta is equal to sin phi into sin delta cos beta plus cos delta cos gamma cos omega into sin beta, bracket complete, plus cos phi into cos delta cos omega cos beta minus sin delta cos phi sin beta plus cos delta sin gamma sin omega sin beta. So by using this particular formula, we can calculate the incident angle. Okay. Now, first of all, find out what are the given information. Because to calculate the incident angle, we must know all the angles related to the sun and earth, angles of the radiation and related to that particular thing. So first of all, we are going to try to find out the given angles, okay, and we are going to find out the given angles, put into this particular formula, and we can calculate the incident angle. So first of all, this flat plate collector is making a 36 degree angle, so that is the beta. Okay, this 36 degree, it is the value of beta, because beta we already know it is the angle made by that particular flat plate with horizontal plane. So this beta is given, that is 36 degree centigrade. Now it is pointing due to west. Now this particular information is useful to find out the value of gamma, which is surface azimuth angle, because directly it is not given. So particularly this surface is pointing towards south, so value of the gamma is 0. So value of gamma will be 0. By using this statement, we can find out. Then third, the latitude. Okay, now latitude is given here. The location of that particular collector, which is installed at the New Delhi, and its location is given here. Now first of all, you must know what is the latitude value and longitude value, because any particular location will identify by using two values. First one latitude and second one is the longitude. So the particularly angle which is came with north or south direction, that is known as the latitude, because we define the latitude like that one. In the northern side, northern hemisphere, if that location it is in the northern hemisphere, we say that it is in the north side, and that particular location, if it is in the southern hemisphere, we are considering at a south. So here it is given 28 degree 35 minutes in north. So that is your latitude. And the second value you will see, that is the longitude value. Okay, so don't confuse in this particular values. You have to use the value which is came with north or south direction. So that will be your latitude angle phi. So this phi angle, it is your latitude angle, and it is given 28 degree 35 minutes. Now another angle, that is the declination angle. For that you have to use the formula. Okay, this particular formula delta. So delta is equal to 23.45 degree into sine in bracket 360 upon 365 into 284 plus n, where n means it is the number of day. Now day is given, it is the May 1st. So by using the number of day, we are just considering 1st January as the first day. From that we have to count up to 1st May. Okay, so that count will be n. Okay, So we have to put that into this particular formula and you will calculate the delta. So delta is also again given, beta is given. Okay. Now gamma, it will be the 0 because this particular surface is in the southern direction or it is due to south. Now remaining is omega. Okay. And for that it is the time of that particular location. It is given, it is 900 hours, means it is 9 a.m. at morning. So first of all, to understand or to calculate the omega, you must know what is the hour angle. Okay, in that case we saw if there is one particular location, okay, when sun is having exactly on the top, that is known as the 12 a.m. So from that one, the 9, which is 3 hours before, or it is in the forenoon, right? And each hour is having 15-degree hour angle. So we just, this 9, the difference between 9 to 12 is 3 hours, and each hour will contain 15-degree angle. So the omega will be 3 into 15 degree. So it will be 45 degree. Okay, that total hour angle, it will be 45 degree centigrade. Okay, sorry, so degree. So put that in this particular formula. All angles we calculated, we got from this given information, all the angles. Just put those angles into this particular equation. As gamma value is 0, so whenever there is any sine gamma, that particular whole term will get cancelled, because gamma 0 is equal to sine 0 is equal to sine 0 degree is equal to 0. So we have to cancel those ones and we have to calculate the cos theta or the angle of incident. So after calculation, you will get the answer, that is theta is equal to 48.9 degree centigrade. Okay, so that's how you can calculate the solar incident angle or just an incident angle. Or again, sometimes it is asked that the angle made by the beam radiation with the normal to the flat plate. Okay, so that is the definition of incident angle, right? Because this one is the normal to that particular flat plate collector, and this is the solar radiation. So angle made by that radiation with normal of that flat plate collector, that we have to calculate, means we have to calculate the incident angle. Okay, so similarly we have to repeat the calculation for the time 1200 hours. So in that case, the hour angle is going to be 0 because the time is 12 at afternoon. So in that case, omega will be 0, other angles will remain same, and we have to calculate the angle of incidence. Okay, so that's how we have to calculate the angle of incidence. So I advise you all that to see the previous video, understand the different types of the angles related to the sun and earth geometry, then you will easily get this particular numerical. And for that, this particular equation is very important, cos theta. On this equation, you can calculate the incident angle. If incident angle is given, you can calculate other angles by using this particular formula. So one of example is there in your assignment. In that case also, we can calculate the incident angle. Just I will tell you the problem. They calculate the angle of incident of beam radiation. They are directly asked you to calculate angle of incident with normal to the flat plate collector on November 30 at 9 a.m. solar time for the location of 16 degree 70 minutes north. So first of all, convert this 16 degree and 70 minutes into degree, okay, into only degree, okay, and then use this particular value. The collector is tilted at an angle of latitude plus 12 degree with the horizontal and pointing to the south. So again here, just gather the given information from the November 30, this particular date, you can calculate the delta, okay, that is the declination. From 9 a.m. you can calculate the omega, that is our angle. Then from the location, latitude is directly given, so this phi value is directly given, 16 degree 70 minutes. So before directly using that particular value, just check this value and convert totally into degree, okay. And then the tilted angle means beta angle, it is latitude plus 12 degree. So this 16 degree 70 minutes plus 12 degree. So that is your latitude, that is angle of beta. and only one angle is remaining, that is the gamma. So gamma is equal to 0 because this particular surface or the collector is pointing due south. It is directly pointing towards the south. So the value of gamma is going to be 0. So by using all those values, just put those values in this equation and you can easily calculate the angle of incident. Okay. So this is all regarding the sun and earth geometry numericals based upon calculation of incident angle. Thank you.